is Becca Windsor. I work with Lutron and I'm based here in Orange County. I work with architects and designers and work with specifications, all things lighting controls, motorized shades, you name it. And today I'm joined with my colleague, Ann Coney.
Sure. Hi, I'm the newbie to the Lutron A&D team. I'm designer and lead AP, and I'm super excited to be here today to be presenting with you guys and working with Becca.
Awesome. Thank you, Ann. First things first, we're going to be talking a little bit about shade automation and daylighting control, and we're going to explore its impact on daylight autonomy. And the purpose of daylight autonomy is really to maximize the useful daylight to limit the need for electric lighting in a building. So in order to do this, we need to consider how daylight impacts the occupants of a space, both positive and negative. And in this presentation, we're going to show how the best way to properly design for daylight is to use dynamic systems, or systems that will adapt based on daylight conditions to optimize for energy and or comfort. And one thing I'll say is that if you have any questions throughout this presentation, just drop them in the chat. Either myself or Ann will respond to those. We'll also have some more time set aside at the end for more questions if you have them. So this program is registered with GBCI and is an AIA approved CEU course. It's also HSW approved for those who need health, safety, and welfare specific credits for AIA. And the CEU is also registered course with IDCEC. And if you need any assistance with getting credit or anything like that, just reach out to me or anyone at AIAOC and we'll get you set up with that. So understand the benefits of daylight and the reality of what happens when the intended daylighting design is not properly maintained. We're going to define daylight autonomy and other daylighting metrics and how to apply them in your designs. And then we're going to learn how daylight autonomy contributes toward current building codes and standards. And then we're going to understand how an ideal automated system would adapt to daylight and climate conditions based on project needs. And lastly, we're going to quantify how shade automation affects the performance according to these daylighting metrics. So we know daylight is highly variable, but can provide exceptional benefits. And when we look at the variability of daylight, it's going to change based on the time of day, the cloud coverage, the time of year, your geographical location, the vegetation outside, etc. So interior lighting conditions can vary dramatically. And what you're seeing here is a picture of an office space. This is in San Francisco. And this two photos were taken on the same exact day. One was taken on the morning of this day on the left, and on the right side, you can see same open office, but it was taken in the afternoon. And it may not be obvious at first, but both of these pictures show the shades and they are using a darker colored fabric. So as you can see, the light intensity, the view clarity, and the light distribution really vary significantly even within the same day. So to further illustrate the variability in daylight conditions, let's look at typical light levels of interior and exterior environments. So most recommended interior light levels are between 10 and 50 foot candles, while exterior daylight conditions can vary between 500 and 10,000 foot candles. So the range of daylight conditions makes it particularly difficult to use passive or fixed shading systems. And those would be things like overhangs, permanent glass tent, fixed louvers, light shelves, etc. And have high performance across all daylight conditions. So the only real way to take full advantage of daylight throughout the year is to use an active dynamic system that is going to adapt to the conditions outside. And so some of the benefits of daylighting, first things that may come to mind is well-being and aesthetics. And we know daylighting has been linked to substantial improvement in the well-being of occupants and is shown to impact overall comfort, mood, health, alertness, and happiness. Daylight provides the correct timing of intensity and light spectrum to help balance the human biological rhythm, like our circadian rhythms. And we know views to the outdoors improve the mood and focus of occupants. And a connection to the outdoors has been shown to improve the well-being of those, for example, in patient care. It can help improve memory function. We've seen it improve student test scores. And another benefit is we can reduce eye strain when we have distant focal points. So when we're indoors, our eyes are generally going to be focused on objects within about 20 feet, but our eyes have the ability to focus on objects miles in the distance. Our eyes are going to actually relax when we're looking out at long distances. So utilizing the dynamic nature of daylight and light spectrum ultimately helps keep occupants alert by providing visual interest as a break from repetitive tasks and static interior environments. We know daylight has been a long-standing tool utilized by architects and designers for centuries by highlighting these architectural elements in interior and exterior spaces. And the intense nature of daylight can really provide a strong juxtaposition between light and dark. And this can also provide occupants with the strong emotional or psychological responses. So playing with light highlights texture and materiality, because without shadow, light is not visible. Another benefit of having a dynamic daylighting system in place is the energy efficiency and operations. So we see that daylighting has an impact on space marketability, usability, and flexibility. So access to daylight is going to be more appealing for leases, employee recruitment, purchase value, and the versatility of daylight application and needs. So for example, we all know window seats in an office are at a premium and everyone wants them. So offices with great views and technologies often rent for more. And having technologies that are adaptive and flexible also allows for more efficient uses of the space. So you're making a smaller area more valuable. And most technologies today are going to prioritize energy efficiency first. However, we realize the most valuable assets in a building are in fact the people. The most expensive operational cost is rent and building maintenance. But once you've taken care of those two systems, then the focus shifts to optimizing for energy efficiency. Daylighting systems are going to reduce the need for electric lighting, and when designed properly, can provide heating energy savings through solar heat gains. So what happens when we don't have an automated daylight system? So this slide represents the lack of movement of manual shades. So on a cloudy day, about 75% of the shades will not move. And on a sunny day, less than half of the shades will move. So for any given day, about 45 to 75% of the shades will likely not move at all and stay shut. For shades that are moved, about 55 to 85 or 80% of them are only moved once. And for any given day, 75 to 90% of all shades are moved one time or less per day. And when it comes to manual shades, only 10 to 20% are actively controlled. So looking at manual control, in this slide, you can see a client or tenant who did take advantage of a system on the 2 floors where shades are aligned and other tenants who did not. The reality of what happens can be seen above. Iconic buildings are developed and seen as masterpieces from a structural perspective, but rarely does the project end up with all the bells and whistles we had originally envisioned. And you can see from the outside of the building, it appears to be unmanaged from a light perspective. In addition, it's evidence that these shades have changed the visual appearance of this building. It's also clear that the intended design has not been maintained, which is incredibly unfortunate considering the time and effort dedicated to designing an iconic building. And I think you'll be hard pressed to find an architectural rendering of a facade with misaligned shades. This building, which is supposed to be the most productive space in its class, requires the occupant to manage their natural light environment. And normally, we would think that the control of one's environment would be empowering and even promote a higher rate of satisfaction. However, in the case of natural light, it is better left up to an intelligent machine. The natural light environment is truly just too dynamic for people to manage and would require a lot of time and effort. I'm sure we've all been sitting at maybe your desk and the light is reflecting off the surface, or you have intense glare and you have to get up and manually shut or open that shade to adjust the light levels. And so if we have a dynamic system in place that automates that for you, we're going to see an increase in comfort, productivity, and so on. So some of the obstacles that we encounter with daylight is energy waste and discomfort. And one of the most obvious obstacles for daylighting is glare control. And this is also the most difficult to achieve without compromising other daylighting benefits. So in spaces with daylighting, glare is most likely the cause of discomfort and reduced productivity. Research has shown that glare can reduce task performance up to 25% in spaces with insufficient glare control. In addition to glare, solar heat gain can make occupants uncomfortable even when the air temperature is at a comfortable level. So the radiant temperature of the sun, glass, and other surfaces can make an occupant perceive the temperature to feel much warmer than it actually is. And for commercial buildings, solar heat gain generally is the biggest source of heat gain that drives cooling energy usage. Even with improved performance in solar control, windows are still allowing significant amounts of solar heat to enter into the building. So providing additional shading to mitigate this heat can really improve the HVAC performance. Generally, facades with direct sun are always cooling. So you're going to see the energy usage here with using shades to, just because daylight reduces the need for electric lighting, it doesn't necessarily guarantee energy savings unless the lighting is properly managed to shut off or dim when not necessary. So all light eventually becomes heat when it's absorbed by an object or surface. So too much light is going to mean too much heat. So the only way to compare daylighting performance is to use metrics. And although daylighting is a very old concept, something that is new and improving our effectiveness in using daylighting metrics and simulation tools. These tools allow designers to compare alternate daylighting designs and optimize performance. The decision to use automated shading on a project is driven by the desire to increase a client's daylight autonomy. A client should want to increase their daylight autonomy because it's going to lead to lower operating costs, a higher return on investment from energy savings, and a more productive work environment. So spatial daylight autonomy, or SDA, is communicated as a percentage of floor area that meets a 30-foot candle illuminance requirement. Assuming glare is controlled, the goal is to get as high a daylight autonomy as possible. And this often requires coordination between the building mason, facade design, interior layout and finishes, and daylighting technologies. Generally, spatial daylighting autonomy is calculated using a daylight simulation tool that computes the daylight levels for every hour of the year across the space. Although there are many alternative daylighting autonomy metrics, spatial daylight autonomy has become the most common due to its inclusion in LEED v4. Annual sunlight exposure, or ASE, is essentially a metric that seeks to minimize the usage of manual shades in a building. And this metric requires the simulation of direct sunlight only without the interior shades. The goal is to design permanent shading devices such as light shelves, overhangs, louvers, etc., that eliminate as much direct solar heat and glare as possible. As a result of designing to minimize that annual sunlight exposure, shades are less likely to be deployed, providing more access to daylight and views. An ASC is defined essentially as the percentage of floor area that receives 100-foot candles or greater of direct sun, which excludes reflections and light from the sky, for at least 250 work hours. And to achieve the LEED v4 daylight credit, you must meet a maximum ASC of 10% of the floor area. However, LEED recognizes that automated shading systems already sufficiently account for direct glare control, so they are exempt from the ASC requirement. Oops, sorry about that. Great. So DGP, which is the daylight glare probability, is essentially defined by the industry to quantify the occupant's perceived glare from daylight. And based on academic research using human subjects, providing self-evaluation of glare. From this research, they developed an equation that estimates glare based on key factors, such as brightness, contrast, light levels, etc. So here are some of the common glare thresholds. For office spaces, it's about 35%. Transitional areas is 40%. Social gathering spaces, 40%. And non-critical glare spaces is about 45%. View preservation is the ability to maintain exterior views to provide occupants with a connection to the outdoors. And views are maintained in two ways. First is opening the shades for more often for unobstructed views. And the second way is to select a fabric that allows views through while closed. Unobstructed views defines the percentage of window that is not blocked by a shading device, such as blinds, louvers, roller shades, etc. And for roller shades, this percentage is represented by the relative position of the shade hem bar in comparison to fully open, which is 100%, or fully closed, 0%. So for example, a shade's deployed to 6 feet above a finished floor on a 10-foot tall curtain wall system has an unobstructed view of 60%. Industry standards reward successful daylighting. So I'm going to turn this over to Anne, who's going to talk a little bit more about how industry standards work with daylighting systems.
So the great thing about dynamic systems is they definitely contribute a lot to these different point systems that we are working with today. And I think, between LEED, WELL, and the Living Building Challenge, they're getting better at working with each other to create synergies. So you will see a lot of the same components between the three will get you points in all three of these systems, and being, a system, they're working together, in harmony. So the first one we're going to look at is LEED. So here with LEED, there's a possibility of 40 points that can go after. Using the systems alone will not get you the 40 points, but what we're helping to achieve is a synergy between the shading system and the lighting controls. So together, you are looking at points in energy and atmosphere that are increasing daylight availability, reducing the need for electric light, and then we're also contributing to enhanced commissioning and automation. We are then able to also take advantage with the materials and the shading fabrics that we're using. We are getting, a more sustainable option with cradle to cradle certifications and looking at different fabrics that are green guard gold and low emitting. On all of the different shades, you should be also looking for HPDs to also help that product declaration. Next with well, we're focusing, on the people, the health and the wellness versus the, the built atmosphere. And here's where with well, the different buckets go into sound, materials, light, and mind. The great thing is even with a passive and, an active shading system, you can address noise reduction. So there are different ways of looking at the materiality to help with noise reduction. And again, like the synergy with LEED, we are looking at materiality where the VOCs are coming into play, material transparency with HPDs, material optimization, looking at cradle to cradle, red list free materials and products that meet REACH. And then another new one that I think has come about, obviously with the pandemic is contact reduction. So using an automated system where people are not having to touch it to automate it obviously is, an advantage. In the light category, you are looking at using the shading with your daylight simulations. You are looking at your daylight design strategies, which are contributing to different points, and just having the light exposure. In the mind category with well, there is obviously points with nature in place and having, your direct line of sight with the choices that you make with your shading systems allows you to preserve those views. It's also going to help create atmosphere. So when you need to create a restorative space, you're going to use different levels of the light and shade to create places that are more of respites for people. And then we're also looking at enhanced access to nature, which means that even with the shades, you're preserving the views, never eliminating, a connection between the indoor and outdoor. And the final system, working with the Well Living Building Challenge. The Living Building Challenge, again, is the most strict, where we're focusing on creating an environment what is healing people and being more of sustainable, in the sense that it's creating its own sufficiency to energy and water. So this system relies on the petals, to get your points. And here we're looking at the petals of the energy petal, where we're contributing to the energy efficiency. Within the health and happiness petal, we again are leaning on the materiality to contribute with green guard gold and creating a better indoor air quality. And then within materiality, also we're looking at PVC free, and even to the point now where your electrical components of the shading drivers and other hardware that's associated with the shading system being compliant with the ROAS, where it's free of the mercury and other red list requirements that are forbidden in our interior environments. So together, I think things are only getting better for the way these systems are improving and working together, like I said, with the different synergies of these different materials. So if you guys have any questions, in regards to specific points, definitely reach out to us with strategies. We can also help with the different synergies too.
Thank you, Anne. Appreciate that. Okay, so We know that an effective dynamic system is going to respond to multiple daylighting conditions. And now that we've kind of gone over the benefits of daylighting, where shade systems are required and the natural variation of daylight, it's important to understand how a dynamic system should respond to different daylight conditions. And there are four primary conditions that are that a good automated system should account for. The first is direct sun, and most importantly, the shades should be deployed to keep direct sun off occupants and the work plane. We also think about high intensity. So direct sun can cause significant glare when reflected off bright surfaces such as snow or a reflective building facade or a body of water. We also look at bright sky. So even if the bright sky causes considerable glare with the high contrast between the sky and surrounding environments. So again, buildings, ground, room interior surfaces, and then of course, dark sky. So if none of these glare conditions are present, the shades should automatically open to maximize the view in daylight. So when we're evaluating the daylight conditions mentioned in the previous slides, there are two common ways of detecting these conditions, each with their own pros and cons. So the first is a rooftop radiometer, which is a wired device that detects both daylight and solar radiation by looking directly at the sky. Since this device directly detects solar heat, it can have an improved response to solar heat. Also, by having a large view of the sky, it doesn't need additional logic to account for things like passing clouds. To predict what is happening in each room, the system requires detailed simulations that need to be rerun every time as the surrounding environment changes. The second is a local window sensor. Typically, wireless devices are located in each room or zone that measure light levels. Since it only measures light levels, a calculation is necessary to allow the system to respond to heat gain. However, there are many unique benefits to having a local sensor. These devices are typically low cost, so converting a few rooms into an automated system is simple and cost effective. And they're generally mounted indoors to make rezoning or remounting simple. And most importantly, these sensors are highly adaptable by measuring local conditions. So they're automated and adjust for changing in the surrounding environment. So cloud coverage, shadows, large reflections, etc. These devices also are not affected by low-level fog conditions that may shadow daylight on lower floors, but not affect higher floors. So we did a case study a while back with Element Architects, and they were looking to renovate their Seattle-based office. And one of the key goals defined by the firm was to really maximize the natural light while maintaining employee comfort and all while saving energy. They considered multiple daylighting system options and set out to evaluate which would work best using daylight simulation. Specifically, they were considering light shelves with and without interior shades. Initially, they believed that light shelves were necessary to achieve their daylighting goals, and they were looking at adding shades to further improve the daylighting performance. When they ran their simulations, though, they found some interesting results. This image shows the interior floor plan for the renovation. The annual metric used here is the useful daylight illumination, or UDI, which is simultaneously evaluating whether a place is underlit or overlit. So simply put, the areas in red are considered useful, meaning they have enough light, but not too much. In this example, they evaluated the light shelf without any interior shades. And it's clear that the perimeter areas were getting too much light, so potential for glare, and too much light to be considered useful. So although there appears to be a pretty large useful daylight area on the building interior, occupants would still need shades and would likely leave them closed. This would have dramatically reduced the useful daylight zone. So this is what caused LMN to consider automated shades as an alternative to light shelves instead of being an addition. This slide shows the useful daylight illuminance for an automated shades only. So as you can see, the useful daylight zone is at least as large as the previous slide and would be much larger than the light shelves with manual shades. They did also look at light shelves with automated shades and found it was only a slight improvement over this option, but at a significantly higher cost. So LMN mocked up both system options to validate their simulations. And ultimately, their research led them to installing automated shades with local sensors in the entire office. This case study really demonstrates the value of dynamic shading systems, particularly automated roller shades. And there are other design considerations that need to be taken into account beyond the selection of automated technology. And so we think of a successful daylighting system is really going to be the right material in the right place at the right time. So some of the other design considerations you'll want to think about is fabric selection matters. Shading systems are really only as effective as the material covering the window. If the fabric is insufficient to eliminate glare, it doesn't really matter where the shades are positioned. Industry tools that allow you to evaluate a material for glare and view performance are going to be really helpful when selecting fabric. And there are types of fabric that are really effective in solar heat rejection. Mockups. Mockups are an effective tool to really understand how a dynamic shading system can integrate with other building systems, like your lighting controls. It can also be used to evaluate the fabric's color, the weave, etc. However, as you've learned in this presentation, daylight conditions dramatically change across the day and season. So mock-ups alone generally are not sufficient for evaluating the entire daylighting performance. Automated systems have been effective at putting the shades at the right position for a typical person. However, there's a lot of individual difference on preference in spaces that are multifunctional. Therefore, it's always recommended to provide a local override to the current automation. So if you do have, let's say, your shade system on an automated system, maybe you want to override those controls. So it's nice to have a local control within that space to have that ability to change it. And most automated systems do have settings that can be tweaked to modify the balance between glare control and daylighting. And some systems even provide helper tools that recommend system changes based on occupant feedback on daylight level in the space. So this is a really effective method of adapting to the needs of individuals or teams. So in summary, why automation? Well, we know daylight is highly variable and changes day to day, hour to hour, minute to minute. And daylighting systems can help provide many opportunities to the occupants, such as wellness, energy efficiency, improved aesthetics, and advanced building operations. For the system to be effective, really needs to account for the obstacles that we talked about, like energy waste and occupant discomfort. And a static or passive system is unable to respond appropriately to meet daylighting needs. In short, manual shades just won't cut it for this. Generally, people don't take an active role in adjusting their shades. Therefore, automation is really needed to maximize the potential of daylight. So when we think about it, automation really is going to give us that balance between glare control, maximizing daylighting for useful daylight space, enhancing and preserving the views, and improving the aesthetics of this space.